Hello there, Mr. Sutton here, bringing you this lesson on special products and factors. In this one, we're going to be simplifying the product of conjugates, and we'll go over what that means in a sec, and also squared binomials. And then we're going to work backwards to factor the difference of squares and perfect square trinomials. For the warm-up, I've given you two sets of what we call conjugates. This is when you have the same terms but with opposite signs. For example, x plus 3 and x minus 3. Your job, after you pause the video, is simply to FOIL these out and simplify them and see if you can pick up on a pattern. Alright, let's see how that went. So for the first one we had x times x, that's x squared. And then x times negative 3 is negative 3x. 3 times x is 3x. And 3 times negative 3 is negative 9. And then these 3x's in the middle are going to cancel out, leaving us with just x squared minus 9. Okay, well that's interesting, but let's do another one here. So 4x times 4x, that's 16x squared. And then 4x times negative 3 is negative 12x. 3 times 4x gives us 12x. And 3 times negative 3, negative 9. Well, these 12x's in the middle are going to cancel out just like the 3x's did, leaving us with 16x squared minus 9. So is there a pattern here? Well, it looks like in both of these cases, those middle terms canceled each other out. And in fact, this is always what happens when you're multiplying conjugates together. The middle terms will always cancel each other out. So we could FOIL these out, multiply these out, and simplify every single time. But it looks like since we have this pattern, we could take a little bit of a shortcut. So if we start with something in the form a plus b, a minus b, basically same terms but with opposite signs, we can do the following. So first thing we can do is square that first thing, square the a here. Notice that the x and the 4x both got squared over in the answer here. So we could call that a squared. We can square the second thing, which is pretty much what happened with the 3's. They became 9's, so that would be b squared. And then notice the sign here. Since you're multiplying things that have opposite signs together, you're always going to end up with a minus there. So just stick a minus in the middle between the a squared and the b squared. So whenever you see something in the pattern a plus b, a minus b, you can simplify it to simply just a squared minus b squared. Now that we've learned a little bit of a shortcut here, pause the video and see if you can use it to quickly simplify the following three examples. Alright, let's see how that went. So for the first one, first term squared is going to be x squared. And then since we have plus and minus the same number, we can just square the second term and subtract it. So that would be 12 squared, which is 144. So x squared minus 144. Alright, on to part B here. In this case, a squared would be 2x squared, so that would be 4x squared. And then 6 squared is 36, so minus 36. And then finally down here, since again we have conjugates, we can square the first thing and the second thing and subtract. So 7x cubed, well 7 squared is 49, and x cubed squared, remember you're going to be multiplying the exponents, so that's really x to the 6th. So 49x to the 6th, and then we're going to be subtracting, let's see here, this is going to be 25x to the 10th, because again we're multiplying the exponent by 2, so minus 25x to the 10th. So a little bit of a shortcut, a little bit faster than FOILing things out and combining like terms. So up to this point, we've seen that if you have conjugates, we have a short way of multiplying them together to get a squared minus b squared. Now this is a little bit of a time saver, especially if you do a bunch of these, but the best use of this is actually going backwards. Let's say that you're starting with a squared minus b squared. So let's say you have the situation of two perfect squares with a minus between them, and you want to factor this. Well, since you know that the difference of two squares is really just what you get when you multiply these conjugates together, we can in fact work backwards to figure out what must have been multiplied to get this difference of squares. So to reverse this process and use it to factor, we're going to have to unsquare the two things that we see here. So we're going to square root the a squared and the b squared. So on this particular problem, that means we're going to take the square root of x squared. And you don't have to show the square rooting, but I'm going to show it just to say explicitly what's going on here. So the square root of x squared, the thing I have to square to get x squared, is just simply x. Square and square root cancel each other out there. And then the square root of 16 is just going to be 4. So once you've got this, we see that we just have a plus b and a minus b. So you're just going to put a and b, the two things you got by square rooting, in two parentheses, one with a plus, one with a minus. So up here we would have x plus 4 and x minus 4. And if you multiply this back out, you'll see that we do indeed get x squared minus 16. So pause the video and try this next example out. All right, so again, we're going to square root these two things and put them in two parentheses with a plus and minus. So square root of 9x squared, that's going to be 3x. Square root of 64 is just 8. And we have a 3x plus 8 and a 3x minus 8. So I think you'll agree this is much faster than trying to factor this the long way. If you wanted to factor any of these things the long way, then you could think of there as being like an invisible plus 0x in the middle. So for this one up here, you'd be looking for two things that multiplied to negative 16 and added up to 0, which would be positive and negative 4. For this one, it would take quite a bit more work. You'd have to use that AC method, which, I think you'll agree this is a little bit faster. All right, let's try one more out here. So give this one a shot. Now, on this one, you might have noticed that we've got a common factor here, so we should always try pulling that out first. And if we do that, if we take out a 5, we see that we have an x squared plus 4 inside. So what can we do with this? Well, you might be thinking we try our plus minus shortcut, but you have to be careful because you'll notice that the key here is that we've got a minus between the perfect squares, not a plus. It turns out we cannot actually factor the sum of two squares. To see why this is the case, let's just do a little sidebar here. Let's say that we have x squared plus 4. Let's just consider that piece by itself. This is really like having x squared plus 0x plus 4. So we're looking for things that multiply to 4 and add up to 0. Now, in order to get a 0 here, we have to have plus and minus the same number. We have to have two numbers that cancel each other out when you add them together. But that's a little bit tricky because to get a positive 4, you would have to have factors that had the same sign, either both positive or both negative. Well, you can't have plus or minus and have the same sign at the same time. You can't have two negatives and two positives and also have a positive and a negative. It's one or the other. So because of this, we will never be able to factor something that is the sum of two squares. We're going to shift gears a little bit to do another situation in algebra. Now, one of the most common things we see in algebra is that we have a binomial and we're trying to square that. And one of the biggest mistakes people make is just squaring the two things inside. For example, a lot of people see this and they just want to write x squared plus 3 squared. But that's not exactly what's going on. So when you're squaring something, you're multiplying it by itself. This is really x plus 3 times x plus 3. So pause the video and actually multiply that out and simplify it to see what we get. And then do the same with this 5x minus 7 quantity squared down here. All right, so up here we've got x times x, which is x squared. X times 3 is 3x. 3 times x is 3x again. And 3 times 3 is 9. So these 3x's in the middle can be combined to give me a 6x to go along with the x squared and the plus 9. So we see here that we can't just square the x and square the 3. We also have that middle term that we would be forgetting about if we just tried that little shortcut. Now this next one here, again, we have this parentheses being written twice. 5x minus 7 times itself. 5x times 5x gives us 25x squared. 5x times negative 7 is negative 35x. Negative 7 times 5x is again negative 35x. And then negative 7 times itself, that's positive 49. So this is going to be 25x squared minus 70x plus 49. So what we've done here is good as far as it goes. It's at least algebraically correct, but it does seem to be taking the long way around. This is one of those situations where we see there's another pattern here. You might notice that we have this middle term being essentially doubled. That middle term is always times 2 to get the middle term that you see over here. So there's got to be a faster way to do these. There's got to be a way to get from the squared binomial all the way over here to the simplified answer without going through all these middle steps. That would be a nice time saver. And in fact, there is. So if you start with something in the form a plus b squared or a minus b squared, we see that that first term in there, the a, is getting squared. So square the first thing. So a squared would be the first step of this. But then we see there's that middle term. And that middle term, you're essentially taking these two things that are in the parentheses, multiplying them together to get these 3x's, for example, and then doubling it because there's 2 of those. So we're going to multiply the first and second thing together, a and b, double it, and put it in the middle. So this would be 2ab plus that, or this would be minus 2ab, depending on whether b is positive or negative. And then finally, to get that last term, we're just squaring the second thing. Either the 3 here or the 7 here got squared. So that would be b squared in this formula. And you'll notice in both cases it's a positive b squared because you're multiplying something by itself. You've got the same signs. You're always going to end up with a positive for that last thing. So we're going to test out this shortcut in just a moment. Now that we've seen this little shortcut here for squaring a binomial, we're going to give it a test drive on these 3 problems. So we'll do the first one together, and then you can try the next 2 on your own. So we have, again, this situation where we have a squared parentheses with a plus or minus in it. We're going to start by squaring the first thing, which in this case is x. So x squared, that's the a squared from this formula. And then to get that middle term, the 2ab, we have to multiply x and negative 9 together and double that. So 2 times x times negative 9. That would give us negative 9x doubled would be negative 18x. And then finally, squaring the second thing, squaring the 9 gives us a positive 81. So you don't actually have to show this 2x times negative 9 part. I was just showing how I got that middle term, but that's what's going on mentally. All right, pause the video and try the next 2 on your own. All right, so for this one, we have to square the first thing. That's going to be 64x squared. Multiplying these together gives us 24x, and doubling that gives us 48x in the middle. Positive 48x, because this was a positive 3. And then finally, squaring the last thing, that's going to give us plus 9. And then finally, this last one. Squaring the first thing, that's going to be 121 x to the 6th. Again, multiplying the exponent by 2. Multiplying these together, we get, let's see here, negative 44 x to the 3 plus 2, so negative 44 x to the 5th, but then we have to double that. So we actually end up with minus 88 x to the 5th. And then finally, squaring the second thing, that's going to be 16 x to the 4th, positive. So I think you can agree we're definitely saving a lot more time on this shortcut than we were on that other one. Now that we've seen how to square one of these binomials, I'm going to throw another term at you, and that's the term perfect square trinomial. That's a trinomial, like something in this form here, that's basically the square of one of these binomials. So although it's nice to have this shortcut for squaring binomials, another side benefit of this is that it allows us to now factor these perfect square trinomials into these squared binomials. So this is another factoring shortcut. The situation here that you need to recognize is when you have what I like to call a perfect square sandwich. That's 2 perfect squares with some kind of middle term. If you have something in this format, then you might be looking at one of these a squared, 2ab, b squared kind of deals. So in this situation, what we can try, like in this example A here, is to unsquare the 2 perfect squares. So square root a and b. Now in this case, the square root of x squared would be just x. Square root of 81, that would be 9. And then put them in a squared parentheses, with the sign of this middle term. So in this case, this would be a plus in here. And this might be the factorization, x plus 9 times x plus 9, of this term here. And in fact, if you think about it, if you multiply the 9s together, you get 81. If you add the 9s, you get 18. So these two things are equivalent. But you have to be careful using a shortcut like this. Although we use the sign of this middle term to get this plus in here, we didn't really use anything else from this middle term. I mean, what if this had been a 17 or a 19 or like a 1 million x in the middle? So with this shortcut, to make sure you actually have the right answer, what you have to do is go back and check to make sure that when you multiply the two things in the parentheses together and double it, you actually do get that middle term that you started with in the problem. So in this case, we're asking, if I take x times 9 and double that, do I get 18x? Well, 2 times x times 9 is 18x, so this does actually check out. So you always have to do this check mentally to make sure that your shortcut actually worked. You don't necessarily have to write this check out explicitly, but you at least need to run that in your head. And if it doesn't work, then you might need to use some other factoring technique to deal with this problem. All right, so pause the video and give this next one a shot. All right, now on this one, we see that we do have that perfect square sandwich. 16x squared and 49 are both perfect squares. So we're going to try square rooting them and using this squared parentheses. The square root of 16x to the fourth, that's going to be 4x. And then 49, the square root of that is 7. And we have a minus here, so that would be minus 7. And this whole thing's being squared. But again, we need to check to make sure that when we multiply this back out, we actually get this negative 56x in the middle. So if I do 2 times 4x times negative 7, what does that come out to? Well, 4x times negative 7 is negative 28x. Doubling that does give me negative 56x. So this checks out, and I can just keep this answer and be on my merry way. All right, let's do this last one. So again, we see that perfect square sandwich. We have an x squared and a 16, so we're thinking, well, maybe this is one of those squared binomials. Square root of x squared is x. Square root of 16 is 4. And since we have a plus in here, if this was one of these shortcuts, it would be a plus 4, quantities squared here. But again, let's check to make sure we actually get this number when we multiply this out. So 2 times x times 4, what's that going to be? Well, this is going to be 4x times 2, that's going to be 8x, and that unfortunately is not the same as 10x. So it turns out this shortcut did not work at all. And that is not the answer. So we would have to go back then and actually factor this using some other technique. Now, fortunately, this one isn't too bad. Since we just have a 1x squared, we can just ask for factors of 16 that add up to 10. And if you think about that, that's going to be 2 and 8. So we could just factor this into x plus 2 times x plus 8. So it is kind of annoying that you have to go back and check to make sure it worked. On the other hand, if it does work, you can save a ton of time. Like on this middle problem here, if you didn't have the shortcut, you'd be using the AC method and be trying to figure out factors of whatever 16 times 49 is that add up to negative 56. So used properly, this can be a huge time savings. This concludes our lesson on special factors and products. Till next time, Mr. Sutton, signing off.